So we are given one assignment. So this is our assignment. We are given the temperature supply, the temperature target, and also the heat. So with the above table, this table, so we have to do three things, which is the hot and cold composite curve, problem table algorithm, and also the grand composite curve. So we have to use four different different delta mean, which is 10 degrees Celsius, 20 degrees Celsius, 30 degrees Celsius, and also 40 degrees Celsius. So now we will show you for delta mean of 40 degrees Celsius.
Right, so for this kind of problem, we can do it in two ways. First, we can use problem table algorithm, or you can either start with hot and cold composite curve. But for this example, we will start with problem table algorithm first. So once you get all the required temperature supply and temperature target and the heat, we need to adjust the temperature based on the T mean given, that is 40 degrees Celsius. So we need to identify which one is the hot stream and which one is the cold stream. In this case, there are 3 hot stream and 3 cold stream. After we apply the formula, then we'll get the adjusted temperature for both of the streams. So you have it here.
After that, we will rearrange back the adjusted temperature from the highest temperature, which is 320, to the lowest temperature, which is 30 degrees Celsius. And then we will do the interval for each stream, C1, C2, C3, H1, H2, H3. And then we will find the difference in temperature between each interval, which is 320 minus 280 for this one, and so on. For the delta Cp, we will use the formula of C hot minus C cold, which one H1, H2, H3 we plus all together minus with C1, C2 and C3. So for the enthalpy, we will get the enthalpy from delta T times with the delta Cp. So 40 times negative 30, you get negative 12,000. So after we get this one, and then we will go to others also until the end, and then we will do the cascade. So for the cascade, we will put 0 at the top, and then we will plus with the delta enthalpy, which is negative 12,000, and then we will get the same thing, and then the negative 12,000 we plus with the next enthalpy to get this one, and so on. After we do the cascade, we will take the most negative value, which is the negative 26,400. We will put it at the top as the QH, which is the hot utility. And then the hot utility, for this one, we will add that with the original enthalpy, which is negative 12,000, and then we will get the 14,400, and then we will add back with the negative 14,400, and then we will get 0, and so on until we get the pinch value, which is 0. And then so the last value here will be the cold utility, which is the QC.
Okay, so for cold composite curve, we construct the graph based on the y-axis and x-axis. The y-axis we put as the temperature, and the x-axis we put as enthalpy. So the 3 line that you see here is based on the question given over here. We'll use the original temperature supply and temperature target and the heat value given in each stream. So as you can see here, for example, in the first cold stream, you can see that temperature supply is 35 and the temperature target is 160, and the amount of heat given in this stream is around 9,000. Next, in order to combine the 3 separate cold stream into one stream, we need to divide it into 4 sections. The first section here, as you can see, we leave it as it is because there is no additional stream in this first interval. But you also need to take note of the amount of enthalpy that is given in this first stream. So for the second stream, as you can see in this interval of the second interval, you can see that there's two different and separate stream with different CP value. So you need to combine the first and the second cold stream CP value, which is 72 and 100. You combine them, we'll get 172, and we'll time them with the temperature difference, which is for T, and then you will get the enthalpy value for the combined stream that you see here. So once you have obtained all the required enthalpy for the combined streams, you can then make a plot based on the temperature difference and the enthalpy that you have calculated earlier. So just connect the enthalpy and the temperature, and then you'll get the cold composite curve. Okay, so do the same for the hot composite curve, and then you'll get this following curve. Next, you transfer it. Once you have both of the hot and cold curve, you can transfer it into one graph. Okay, so now once you have established both of this curve, you can then calculate the amount of required hot utility, which is 26,400 kilowatt, and the amount of cold utility, which is 14,600 kilowatt, which is the same amount of utility that we have obtained earlier in the problem table algorithm. So based on the problem table algorithm that we have obtained earlier and the composite curve of the combined composite curve of hot and cold curve, we can construct the grand composite curve that you see here based on the temperature and also the enthalpy.